This screencast will cover part D of the Topic 4 Cycle 2 Apply Lab, Table 4, and the final graph of energy versus stretch. In this case, I'm just going to concentrate on the one rubber band stretch that we've been looking at so far, the 4 centimeter or 0.04 meters stretch. Go ahead and enter the information that we have. We know that the mass of our car in marble, as we've recorded before, is 0.1 kilograms. The photogate time and speeds are things that you recorded directly during your measurements. Now, when I was doing the lab, I found that my photogate time was 0.0080 seconds. Okay. And also, my car went to a height of 10 centimeters, so that would be 0.10 meters. And just a note on this one, on that height, as it went up, here's my rubber band here. It went to here. This was at a height of 11 centimeters from the table. This one was at 21 centimeters from the table. So the difference between those was 10 centimeters, or 0.10 meters. Just make sure that's clear on how we do that. It's the distance, the difference in the distances from the table. Okay. Now I want to go through and figure out what these values are. Speed. And for our speed, we're pretty good at this calculation now. Is 0.1 meters. That's the length of the tab on the car divided by the time it takes to go through the photogate. So I have a speed of 1.25 meters per second. That's a pretty reasonable value. I'll put in 1.25. Sorry that it's written over the entry below. Okay. Let's figure out what the kinetic energy is given that speed and that mass. Our kinetic energy is 1/2 times mass times velocity squared. This is going to be the velocity that we actually measured for the car. So 1/2 times my mass, 0.1 kilograms, times 1.25 meters per second squared. And remember, PEMDAS, we'll have to do this first. I multiply that all out, I get 0.078 joules. I'll put that here. 0.078 joules. Notice that that happens to be less than the the elastic potential energy where it was stretched out. Some of our energy obviously went some other place. Think about that as part of your analysis. For our gravitational potential energy, we're going to take a look at this. Again, we know it's mgh. In this case, our mass is 0.1 kilograms. Gravity, we can assume 10 meters per kilogram, 10 newtons per kilogram. And our height in this case was 0.1 meters. Let's see what energy we get from that. At 0.10 joules. I'll go ahead and enter that in here. 0.10 joules. Again, this is a little bit less than the 0.12 joules that we determined was stored in the rubber band. Again, think about ways that energy might be dissipated. Go ahead and continue on with these same calculations for the other values that you've got entered here. The last thing we'll be doing is, in our final table, is plotting the value of elastic potential energy from table 2 onto a graph versus stretch. But we're also going to be looking at the kinetic energy that we actually determined we had and the gravitational potential energy. Let's take a look at that. The last item here is to plot the energies against the the amount of rubber band stretch. I've already plotted a couple of these. Our elastic potential energy, and from table 2, the amount of stretch and the amount of energy. Then I've also plotted the elastic potential, gravitational potential, and put that on here. And then I would go back to table 4 to look for our kinetic energies. And it has a note, go ahead and put in 0, 0. And as I go along, I'm just, let's see, I would end up finding these points here. I think our last one was like around, let's see, that was around 0.7, and then maybe I'll point out about here. And end up making my curve through here. Just one thing you'll likely note is these are not straight lines. They'll end up forming some type of a either steeper or shallower type of parabolic curve. And this one I would mark kinetic energy. Just to note, there was a typo on some of the early versions of the lab, and it didn't include the kinetic energy. Please go ahead and include kinetic energy. We'll talk about that in class, and if you read between the lines there, you'll see that the requirement is to plot the kinetic energy as well. Okay, good luck with the lab. Hope everything goes well.